11? Was it factorable? No. Okay. Cannot be factored by it can't be solved by factoring. Okay, so sometimes, but could you graph it? I mean, so does it exist? Okay, so today we're going to find another way to solve it. Okay, so I'm moving through these fairly quickly. You know, either you're factoring it and you're using the zero product. You know, we spent a lot of time on factoring. You guys know how to graph. We're going to do another one. And this one, well, let me just give you a little bit of history. So please take out your notes. Okay, and I guess I really love history. Okay. Now remember, my generation was not the graphing calculator generation. So think about this. In 2000 BC, the Babylonians were able to solve quadratic equations, okay, using the equivalent of substituting in a general formula or by completing the square. Okay. I don't know about you, but I stand in awe in that thought, that in 2000 BC, that they were able to do these quadratic equations. It humbles me when I think about that. Okay? So, we are going to learn, and we're going to talk about the quadratic formula. Now, think about it. And we all know what the quadratic formula is, right? What?
A equals x squared.
A equals?
No, y equals.
Okay, y equals
ax squared
ax squared
plus bx plus c.
plus c. Okay?
It's not messed up, Dan, it's different.
Okay, we're going to talk about it. This is the quadratic equation. And we're going to talk about the quadratic formula. Okay? The quadratic formula is a nice formula, very, very handy. And I'd like you to copy this down.
Thank you for keeping Dan in mind.
And your homework tonight, I'm going to give this, I might give this to you over a couple of days, is to figure out how did they go from this to that? Because that's all that is.
Mr. Kelly taught us that last year.
Did he teach you how to get there?
Yeah.
Okay. It is very long, and I will talk about it in a second. So the quadratic formula, and please make sure you write this down in your little notebooks.
Wait, what's under the plus sign?
Hold on, I'm going to read it to you in a second.
goes.
Equal to or?
The quadratic formula. For any a quadratic in standard form, ax squared plus bx plus c equals 0. Okay. The exact solutions, because remember we said by graphing we can't always find the exact, but the exact solutions or roots, okay, we know that when we have equations, we have roots, are given by this formula. And I'll read this to you. X equals, and it is a minus b plus or minus the square root of b squared minus 4ac,
The square
and
root
that whole thing is over 2a.
Oh my god.
Okay? And I'm not going to, I will definitely go over it with you, but for now, I would like you to ponder that and be a mathematician and think about, could you get there? Could you get there from here, as they say? Okay? So that is the equation that we're going to use, and do you think it's going to be pretty handy? All right. The other thing that I would just like to point out to you, if I had, let's say, a plus b over 3, could I also write this as a over 3 plus b over 3? Okay. This is two distinct this is a fraction over one common denominator, but I can pull it apart. And the same is true with this, and people forget that. This whole thing is over 2a, and I can write that as minus b plus or minus the square root of b squared minus 4ac, and I could put this over 2a, and I could put this over 2a, and I will show you shortly why that is a good thing to do. Well,
So wait, they're the same exact equation, it's just the second one is more exact.
I'm sorry, say the question again. They're the,
They're the same,
what's the same?
that equation and that.
This
Yeah.
has been rearranged, and what have they done? They've moved it around. I mean, okay, so is that any different than if I had 2x plus 3y equals, let's say, 24? Can't I rearrange this equation to get y by
Yes.
itself?
But didn't you say that that one's more exact? Like it's,
Oh no, it's a more exact way to solve for x than what we have been doing. We've been graphing it. We've been factoring it. Factoring is exact, but if we have a quadratic that's not factorable, then what?
yeah.
Then you don't know what to do. Okay? And if I want an exact answer and graphing is rounded, then what do? Ta-da! You have the quadratic. Okay? And that's why we're learning. There are multiple ways to solve this problem. Okay? All right, are you ready? Everybody ready to go? Okay. And I have to tell you, the worst part about these problems is there's no room for error. Those of you who are sloppy, those of you who don't write things down, you're gonna drown. Okay? This is about really paying attention to detail. Okay? It means paying attention to detail. And what I tell my students, and you need to memorize this formula. This is like the back of your hand. You know this formula. Okay? This is not like, oh, I don't remember that. You mean we have to memorize that? Yes. This is one of the few times that I really say to you, you need to memorize this and know this blank. All right, so everybody has this one down? Okay, have it in your book. Okay, so do we know what the A is? Do we know what the B is? And do we know what the C is? Yes? This is, these problems in some ways are just a plug and chug. You're plugging in the numbers and you're chugging along. But I'm asking you that you please make sure that you're very careful. I always start with x equals minus b plus or minus b squared minus 4ac. I'm putting the whole thing over 2a.
Wait, how do you know if it's plus or minus?
It isn't the square root of any number always could be a positive. If I said, what is the square root of 4? Well, couldn't my answer be plus 2? Or couldn't it be a minus 2? Okay? So I always have a plus or a minus. And we'll see what happens with that. Okay? So I'm going to literally copy x equals minus. I look at my b. What is b? It's a negative 4. Please make sure, and this is where people trip up. They trip up on those negatives by plugging it in. So it's going to be minus b plus or minus. I have negative b squared. Doesn't matter in this case because I'm squaring it. Here's where the other error is. It's minus 4. What is my a? 3. What is my c? Negative 7. And that whole thing is over 2 times 3. Please, please, you're going to write your formula and you're showing me what you have done. I can at least give you partial credit for doing that part right.
So
Okay?
it's like a plug and chug.
It is a plug. I mean, at this point, that's all it is. So, x equals, what is the opposite of a negative 4? Positive 4, and I'm gonna have plus or minus. What is 4 squared? I have 16. This is where the errors occur. A minus, so you can, order of operations, I can multiply in any order. So I'm gonna look at maybe 3 times 4 is 12, right? 7 times 12 is 84, and I have a negative times a negative, so my answer is going to be what? Positive 84,
I have a question.
and that whole thing is over, what, 6? What's your question?
When it says b squared minus 4ac, is that like b squared minus 4 times ac?
Order of operations, I have to do this multiplication before I do subtraction. Okay, so it's minus, but there's multiplication here, so I know I have to do my multiplication first. So I have x equals plus 4 plus or minus, what is 16 plus 84?
100 is 10.
It's 100?
No, well.
100 over 6, okay. I just want to make sure, I want to take it step by step. X equals plus 4 plus or minus 10 over 6. Again, order of operations. I have to do what's in this numerator first. Now, this is saying it could be a plus 10 or it could be a minus 10. So x equals, I'm solving the problem twice, exactly. 4 plus 10 is 14 over 6, or x is equal to 4 minus 10 is a negative 6 over 6.
So it's
I can simplify them. X is equal to a negative 1, or what do I have here?
2 1/3.
I'm leaving it as an improper fraction, so I'm gonna have what, 7/3? 7/3. Okay, please graph the original equation, and let's see what that looks like. What did we solve for?
Bruce.
And what would,
Zero.